This is the EME presentation of Group 20 on what keeps Europa's oceans warm. The reason Europa is of interest is it's Jupiter's fourth largest moon, but more importantly, proposed to be one of the most logical places one could look for life in our solar system other than Earth. As we understand life, it requires liquid water, and Europa has more than double the amount of Earth. But as far away as Jupiter, it's very, very cold. So how, at a temperature well below the freezing point of water, could there remain liquid water? Our hypothesis would be that there are tidal heating mechanisms at work maintaining liquid water temperatures. In order for the temperature to remain roughly constant, maintaining the liquid water temperatures, you need an energy inflow equal to an energy outflow. Otherwise, you wind up with an accumulation. Earth receives an irradiance from the Sun of about 1361 watts per meter squared at a distance of 1 AU. Since Europa is roughly 5.4 times further away, we can use the inverse square relation of light propagating outwards to calculate that Europa would receive about 44.6 watts per meter squared. Factoring in the reflectance of the surface being 2/3, only 1/3 is absorbed. Roughly 15.5 watts per meter squared is absorbed. Times the cross-sectional area of Europa, we calculate roughly 1.2 times 10 to the 14 watts is absorbed. For the energy outflow, we use the Stefan-Boltzmann relationship for the total power radiated by a black body, assuming an average temperature of 110 degrees Kelvin over the times the surface area of Europa and emissivity of ice. We calculate that roughly 2.4 times 10 to the 14 watts would be radiated away from Europa. This value is roughly double what Europa would receive, so there has to be another source of energy to keep Europa's temperatures warm enough for there to be liquid water. If we reverse the Stefan-Boltzmann calculation, we can estimate that Europa would be around 92 degrees Kelvin if there was no other warming, setting the outflow equal to the inflow we calculated from the Sun. A partial source of the energy would be the radioactive decay of heavy elements in the core, but the majority would come from what is called tidal heating. Tidal heating is caused by the fact that one side of Europa is nearer to Jupiter's center of mass than the other. This causes a difference in gravity between the 2 points, which leads to a fluid flow from one side to the other. You could roughly think about this as being analogous to losses in a pipe flow, but certainly not being equivalent. We could roughly think that the gravity and the motion of Europa around Jupiter as being a pump head supplying energy into the system, and some of that energy will be dissipated in a form of heat due to the friction acting on the flow of the fluid from one side to the other. As the water bumps into the rocky center or the icy top or even itself, it creates heat. In addition, there are also conductive effects which lead to additional flows and additional heat dissipation within the system. In our conclusion, Europa is capable of maintaining liquid oceans because there's a frictionless loss from the flowing water beneath its icy crust. Because of this, it is able to stay warm enough to remain liquid. And liquid water is, as we understand, a requirement for life, making Europa a very large topic of interest for many astrobiologists. The fluid flow in Europa from one side to the other is reasonably large. I mean, if you think about the effect the moon has on our oceans, imagine how much that would be if it was being affected by Jupiter. A full quantitative description of this system would require not only a very large computer simulation, it would be incredibly difficult to actually make accurate assumptions about the interior of Europa and have good boundary conditions imposed. Scientists have in fact observed that there is water beneath the icy crust of Europa, and if it were not for the tidal heating that occurs within, then Europa would be much colder off and be a big chunk of ice, far more comparable to a comet, rather than being one of the most fascinating celestial objects within our solar system.